Hello everyone. Today we are going to look in detail about one of the major OOPS concept, encapsulation. You might already have a brief intro to encapsulation in Java from OOPS overview episode. Encapsulation is defined as the wrapping up of data and the code under a single unit. That is, it is the process of binding the data and the code into a single unit. The data can be termed as variables and the code as methods. Encapsulation keeps data and code being safe from interference or misuse. This mechanism binds the code and data it manipulates together. Thus, it is a shield that protects data being accessed from outside objects. This is somewhat can also be termed as data hiding. Encapsulation and data hiding are interchangeable. Few people would say encapsulation is a combination of data hiding and abstraction. Popular real world example would be capsules. In encapsulation, the variables or data of a class is hidden from any other class and can be accessed only through any member function of its own class in which it is declared. Now, let's look at a hypothetical situation for encapsulation from programming perspective to have better understanding. Assume you wrote a code for a class, say this R class, with public instance variable model. Then there are 50 other programmers in your company who all wrote programs that used your class. After some time, you didn't like how your class behaved because other programmers set values to the class instance variable that you didn't anticipate, which in turn brought errors on your code. Well, it is a Java program, so you should be able to publish a newer version of your class by changing your class behavior. Of course, other programmers should be able to replace the older version without changing any of their own code. But will that be possible in this situation? No. As soon as you change the code, all other programmers will be affected and they must change their code. If you are yet to be 100% clear, let's take the code snippet example. Here, car class as an example with the instant variable model defined as public. And we have a demo class where an object is created for the class by one of the programmer and sets the value for model variable as v6. Now, how are you going to change your car class public variable without changing this code? The moment you change the public variable to protected or private, everyone else code is going to break. Your ability to make changes in your implementation code without breaking the code of others who use your code is a key benefit of encapsulation. Hence, you should hide the implementation. By hiding the implementation details, you can rework your method code without forcing a change in the code that calls your changed code. If you want maintainability, flexibility, and extensibility in your design, you must include encapsulation. Your question would be, how would you do that? Don't give public access to instant variables. I would strongly recommend to always define instant variables as private. Some people might say it is okay to give protect when inheritance is involved. Again, the scenario I spoke of can happen and become a headache. So keep all the instant variables as private and define getter setter methods to access and set values for those variables. Example, now this is ideal way to write code. You can check the output by creating object and using getter setter method like this. This particular scenario highlights two major benefits of OOPS, flexibility and maintainability. But these benefits won't come automatically. You have to write your classes and code in a way that supports flexibility and maintainability. Though Java supports object orientation, it can't design code for you. You have to write code in such a way. Remember the previous videos where I had mentioned instant variables should not be declared as public. This is the reason behind it. Those programmers who seriously consider code design might wonder this code does not even do any validation or processing. What can be the benefit of having getters and setters that does not add any additional features or functionality? Well, point here is in future, if you decide to make changes, you can do without breaking your API. You can add or remove functionality at your desire. Even today, if you are not validating or processing, a good design should indicate that you plan for the future. By forcing other programs to call your getter and setter methods instead of directly going to instance variable, you are free to rework your method implementation later on without risking the wrath of those 50 other programmers. Any IDE that supports Java platform, there will be an option to encapsulate class variables. In IntelliJ, you can right click on the variables, refactor, encapsulate fields. All domain objects in Java are defined with encapsulation for data integrity and security purposes. Almost every application in Java could have encapsulation. Advantages of encapsulation. Data hiding. It is the process of restricting the access to data or variables by hiding the implementation details. Encapsulation also provides a way for data hiding. The user of your class will only know they are passing to a setter method or the value they get. They will not know how the class is storing values in the variables. Flexibility. As you had seen in our example, changes to a single part of the code will not affect any other part of the code. Encapsulation enables you to rework your method implementation whichever the way you want without affecting those who uses your code. Maintainability. Encapsulated classes are easy to maintain and also provides extensibility. You can add whatever you want to the method implementation. Control. It provides superior control over the data or variables of the classes. Security. It prevents direct access to variables by any external classes. Acts as a protective shield by avoiding any misuse and thus enhances security. Reusability. As it provides flexibility, maintainability, and extensibility, it also improves reusability. In case of new requirements on base features, you can easily reuse the encapsulated code and add new functionalities. Easy to test the code. If you are writing unit test cases for testing your code, encapsulation makes your life easy. Encapsulation versus abstraction. You might wonder by now, both abstraction and encapsulation in some manner performs hiding. How encapsulation is different from abstraction? Well, except for both are OOPS features, they are not the same. Let's look at differences between encapsulation and abstraction. Abstraction is a process of showing only the essential information that is needed and hiding the non-essential information. Encapsulation is the process of wrapping up of data and the code under a single unit. In abstraction, the problems are solved at design level. In encapsulation, the problems are solved at implementation level. Achieved through abstract classes and interfaces. Achieved through access modifiers. Abstraction focuses on what should be done, that is external outlook. Encapsulation focuses on how it should be done, that is internal working. Abstraction is the process of gaining information. Encapsulation is the process of containing the information. Encapsulated objects help to perform abstraction. Encapsulated objects need not to be abstract. Let's recap with a quick 2-minute summary. Encapsulation is defined as the wrapping up of data and code under a single unit. Encapsulation keeps data and code being safe from interference or misuse. It is a shield that protects data being accessed from outside objects. In encapsulation, the variables or data of a class is hidden from any other class and can be accessed only through any member function of its own class in which it is declared. If you give public access to variables in your class, then you are exposing the entire state of your class and entrusting whoever uses it to properly use them. If they misuse and when you want to change, it would be impossible for you to change your class without affecting all the other classes that is calling your class. To avoid such cases and have ability to modify your class the way you want, we encapsulate the fields. We encapsulate by defining instance variables as private and have public getter and setter methods to get and set values to these variables. In any IDE that supports Java platform, there will be an option to encapsulate class variables. All domain objects in Java are defined with encapsulation for data integrity and security purposes. Almost every application in Java would have encapsulation. Advantages of encapsulation: data hiding, flexibility, maintainability, control, security, reusability, and easy to test the code. Difference between abstraction and encapsulation: abstraction is a process of showing only the essential information that is needed. Encapsulation is the process of wrapping up of data and code under a single unit. In abstraction, the problems are solved at design level. In encapsulation, the problems are solved at implementation level. Abstraction is achieved through the help of abstract classes and interfaces. Encapsulation achieved through access modifiers. Encapsulated objects help to perform abstraction, whereas encapsulated objects need not to be abstracted. After every topic, there will be a set of questions with multiple choice options, which you can use to self check your skills on that topic. These are derived by me for the topic. You can find the answers in the video description. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question. Second question. Third question. Fourth question. Fifth question. Try out by creating classes with encapsulated fields, that is, variables declared as private with public getter and setter methods. Create another class with the main method which will create objects for the classes with the encapsulated fields and try to access and set values to the variables. Encapsulation is one of the most critical parts of Java programming. Almost every application in Java would have encapsulation.